Hi there, and welcome to the Air Equipment LLC YouTube channel. This is part 4 of our discussion about the basics of fans and blowers. There's an interesting dynamic taking place in the commercial HVAC world nowadays. A lot of fans and blowers are being specified as direct drive, when we would have used belt drive in the past. And so let's talk a little bit about the difference between belt drive and direct drive fans. At Air Equipment, I have the honor of being the person who gets to go to the job sites and do the maintenance training seminars for the facility staff. And so when I go to these meetings and I tell the facilities folks what they need to do to maintain the fans that have been supplied and installed in their buildings, the first thing we talk about are the belt drive fans. And so I have the O&M manual and I go down the list of exactly what needs to be done to service those fans. And the first thing is we got to tighten all of the set screws that hold the sheaves and bearings in place. With a belt drive fan, of course, there's a shaft and there's two bearings that hold that shaft in place. And at the bottom end is the centrifugal impeller. At the top is a pulley. And that pulley is connected via a belt to the pulley that's on the motor. And when the whole assembly spins, that's how you get the impeller to move and create airflow. But the two bearings have set screws, these small little round things. You need an Allen wrench to tighten them. And the set screws are what hold the shaft tight to the race inside the bearing. And it's very important that they're tight. If they wiggle loose, then that shaft can start to free float inside the fan. And when it's spinning 1500 RPM and not being held in place, it can cause a lot of damage when it hits something. So those need to be tightened. There's also the same kind of set screws that are on that hold the pulleys and the sheaves in place. They need to be checked and tightened, and this maintenance needs to be done at least every quarter. So that's step one. Tighten up all the nuts and bolts and screws. Just make sure nothing has wiggled loose. Next, we have step two. We have to check the alignment of the pulleys. The only proper way for the pulleys to be set up are square to each other and on the same plane. So if, as you can see here, there's only one correct way, the upper left-hand image shown, sometimes the motor pulley is higher than the fan pulley, or sometimes it's lower, or sometimes the motor's kind of cocked off to the side. Those are incorrect. Just imagine the orbit that the belt's taking. It's going to just disintegrate in a very short period of time. So the pulleys have to be aligned, and if they're not, then the way to adjust it is to loosen up the motor from the motor plate and move the motor, move it up, down, left, right, whatever's necessary to get those pulleys back into alignment. And then while we're looking at that, we have to check the belt tension. Now, the unfortunate thing about belt drive fans is when the fan ships from the factory, even if it has perfect exact right belt tension, over time the rubber in that belt stretches. And so after 3-4 months of operation, it's quite common that the belt is loose because it's stretched out a little bit. So if it is loose, then what has to be done is, again, loosen up the motor side and pull the motor away from the center, and that'll tighten up the belt. And then it's usually a two-man job. One guy's holding the motor in place and the other guy socks down the bolts to lock it in there. And then finally we have step 4. We need to grease the bearings. The two bearings that hold the fan shaft in place, they need to be greased on a regular basis. The more the fan operates, the hotter it operates, the faster it spins, the more often it needs to be greased. So that really depends on usage. But again, during routine maintenance, it has to be looked at and done. Having loose belts where the fan is squealing and slipping and making noise and the belt disintegrates and breaks long before it ought to, that's the most chronic problem we see. But having bearings that don't get greased and they totally dry out. And just imagine if you drove your car down the interstate at 70 miles an hour with no oil in the engine. You would have metal on metal getting really hot. It would expand, seize up, and you'd blow the engine. You would ruin your car. Well, the same thing can happen with fans. When those bearings dry out, when they don't get greased, and you have a fan spinning at 1500, 2000 RPM, suddenly you're going to have metal on metal with no lubrication, and that bearing's going to seize up, and the fan spinning really fast is suddenly going to stop on a dime, and it usually ruins the fan. So the most chronic problem we see is loose belts. The most catastrophic problem we see is no grease in the bearings, and it often destroys the fan. So those are the steps that have to be done on a regular basis, usually quarterly, with every belt drive fan on the project. Then, after talking about the belt drive fans, I explain to the facilities folks what they need to do for the direct drive fans. The first step is to inspect the fan and make sure it's running. And then the second step is, oh wait, there is no second step. That's it, you're done. So from a maintenance point of view, the direct drive fans are so much more simple. At this point in the presentation, when I do this for facilities guys, they usually say, hey, wait a minute. There was 20 new fans installed on this addition to this building. 15 of them are belt drive, and only 5 are direct drive. Why aren't they all direct drive? You know, from their point of view, they want the least amount of maintenance. The thing is, our industry is leaning in that direction. We are using more and more direct drive fans whenever possible. And some of the new technology in motors and in controls are allowing us to do that. But that's not to say that belt drive fans are going away, because there are some advantages of belt drive fans. So let's just take a quick look at some of those. First, the fan RPM can be higher than the motor RPM. With a direct drive fan, whatever that motor is spinning is what the fan impeller is spinning, because they're directly coupled. And if the motor has a maximum RPM, then that's the maximum the fan can go. Sometimes you might need that fan to spin faster. With a belt drive fan, just by having different size pulleys, you can have the fan impeller going faster than the motor. And in certain applications, that may be what you really need to do. Next, it's much easier to install a new motor on a belt drive fan. Usually the motor is outside the fan housing. It's on its own little motor mount plate. Much easier to swap out, put a new motor in, compared to a direct drive fan where the motor is almost always deep into the housing of the fan, directly coupled to the wheel. It's quite an ordeal. With belt drive fans, we still can ramp up the speed as needed just by using a VFD. We've been doing that for many years in the industry. And then finally, the motor's out of the airstream. Certain applications, maybe it's some kind of fume exhaust. If the motor is right in the airstream, it might damage the motor. So with a belt drive fan, the motor's typically nowhere near the airstream, and that can be an advantage with certain applications. By the way, if you do specify a belt drive fan, please include the automatic belt tensioner. It's a simple little third pulley on a spring-loaded arm, and it puts pressure on the belt. As the belt stretches out, it just pushes the belt a little farther out and makes the tension on the two important pulleys, the motor pulley and the fan pulley, that tension is correct. It never gets too loose. It's a simple little feature. It doesn't cost very much at all, and it extends the life of the belt sometimes 2 or 3 times its normal lifespan. It's a great little feature, so make sure you include that in your specs. All right, let's take a look at the advantages of direct drive fans. Well, first, less maintenance, which we just discussed. A lot less maintenance. The facilities folks at the buildings love direct drive fans. Next, it's lower cost. A direct drive fan does not have a fan shaft and a motor mount plate and bearings and pulleys and a belt. That's just a lot less components that are not part of the construction. So it saves money. And even with a more expensive ECM direct drive motor, typically compared to an equivalent belt drive model, it's still less expensive. So direct drive fans cost less. Very easy to balance. Usually it's just a little turn screw, a little knob to dial in the CFM you want, which is quite different than balancing a belt drive fan, which is pretty, the balancer has to take his reading, then he's got to shut the fan off, basically disassemble, loosen up the motor, take the belt off, adjust the pulley, tighten it back up, put the belt on, reset the motor. It's quite an ordeal for the balancing contractor to balance a belt drive fan compared to direct drive, which is simply turning a little screw. Also, direct drive fans are more efficient. We don't have any drive losses, or belt losses as it's sometimes called. With a belt drive fan, whatever amount of horsepower is needed to be applied to that impeller to get the proper airflow, the motor has to output more than that because some of that energy from the motor gets lost in friction between the pulleys and the belt. So if, for example, a fan impeller needed 1.9 brake horsepower of energy to get the proper airflow, the motor might have to output 2.1 brake horsepower, because anywhere from 5 to 10 to sometimes up to 15% of the energy is lost in that drive assembly, the pulleys and the belt. So switching to a direct drive fan just right off the bat saves 5, 10, 15% on the electric bill. So it's very much more energy efficient. In our next segment, we're going to discuss the ECM motor, a very exciting new option in the world of commercial HVAC.